Hi, let's take a look at real beams because there's some oddities here when we learn about and develop the stress model for transverse shear stress in a beam compared to how the beams behave in real practice, right? On screen, you'll see that we have a reinforced concrete beam. It turns out that it was tested in what we call three-point testing. The two supports at either end would be two of those points, and then the point of loading application would be the other one. And notice that this crack in the beam, very large, this beam has been cracked to failure, but that crack at the top is emanating out of where the actual load was applied, and then it propagates at an angle down through the bottom of the cross section. This is a reinforced concrete beam. If you look real closely there down the bottom, you can actually begin to see where the steel reinforcing bar is going through that very wide and really exploded out piece of concrete. That's a little strange because remember, transverse shear is perpendicular to the long axis of the beam. In other words, parallel to the cross section. And the cross section would be vertical here, and yet what do we have? We have a diagonal crack. That's a little strange for a model that's really going to predict the shear stress on the vertical. Sorry there. Okay, now the other part that I want you to take a look at is this glue lam timber beam that we have down here below. Here you have horizontal layers of 2x8s or 2x6s, 2x4s, that kind of thing, all laid up horizontally, and then they are bonded together through an epoxy. It's laminated, and because it has multiple layers, and then it is glue laminate, it's really more of an epoxy than it is a straight glue, right? And notice here that the cracking or the splintering or the splitting that has happened in this wood member is horizontal in nature. Again, that's not the transverse cross section, and that just seems kind of weird, right? So we're going to explore this in greater depth. If you remember, though, back from when we looked at torsion and the shear that was going on there, when you looked at a tiny little differential element, there was a shear stress that was happening that was the same magnitude on 90-degree planes, right? And so there's something that's going on here too that we'll get into. But here are just two simple examples of real shear failures in beams.